Okay, so on number 1, it says to convert negative 270 degrees to radians and express our answer in terms of pi. So we should know that 270 degrees would typically be here. So we don't necessarily care that 270 degrees is negative, except for the fact that 270 degrees would be equivalent to 3 pi halves. But since this is negative, then our radians should also be negative. So this would be negative 3 pi halves. They ask us to convert 234 degrees to radians and express it in terms of pi. 234 degrees is not on our unit circle, so we're not expected to have that one memorized, so it does say we're allowed to use our calculator. To convert 234 degrees into radians, all we do is multiply our degrees by pi over 180. If it helps, I can always put this over 1. I multiply numerators, which would be 234 pi over 180. And then I would just simplify 234 over 180, which I can do in my calculator since a calculator is allowed on this question. And this would simplify to 13 pi over 10. Number 3 says to convert 5 pi fourths from radians to degrees. So 5 pi fourths is one from our unit circle. So we should have 5 pi fourths memorized. 5 pi fourths is equivalent to 225 degrees. They ask us to convert 3 pi over 10 into degrees. This one is not from our unit circle, so we don't have to have it memorized. I would simply multiply by 180 over pi. And here my pi's will divide out, and I multiply 3 times 180, which would give me 540, and I put that over 10. And then I simply divide by 10. My zeros cancel out. This is 54 degrees. Number 5 says to find 2 angles, one in a clockwise direction and one in a counterclockwise direction that is coterminal with 143. So coterminal means they share a side. If they share a side, that means it has to go all the way around the circle. An entire circle is equivalent to 360 degrees. They said we need one that goes the clockwise, one that goes counterclockwise. In other words, I need to add and subtract 360 degrees from 143. So 143 plus 360 would be 503 degrees. And then 143 degrees minus 360 would give us negative 217 degrees. For number 6, it says to find the same thing, coterminal angles, but for negative 2 pi over 11. So I, again, am going to add and subtract a full circle, but since this is in radians, we are adding and subtracting 2 pi, since that's equivalent to 360 degrees. Now, if I'm going to do this without a calculator, I need a common denominator. So I'm going to have 2 pi over 11 plus 2 pi, which is going to need a common denominator, and negative 2 pi over 11 minus 2 pi, which again we need a common denominator for. So I need to turn 2 pi into something over 11. Well, 22 divided by 11 is equivalent to 2. So I'm going to add 22 pi over 11, and I'm going to subtract 22 pi over 11. Negative 2 plus 22 is 20 pi over 11. And negative 2 minus 22 is negative 24 pi over 11. So this would be 20 pi over 11 and negative 24 pi over 11. All right, and then for the following, we are to give our exact values. So cosine, either use your left hand, and that would be your index finger that you bend, or you visualize a triangle with a 60-degree angle. Okay, if I'm using my hand, cosine is number of fingers to the left, which would be 1. The square root of 1 is 1, always over 2. If I'm looking at the picture, cosine is x, which would be 1 over r, which is 2. Number 8 asks for cosecant of 2 pi. 2 pi is this coordinate over here, 1, 0, where r is always 1. Cosecant is r over y. R is 1, y is 0, 1 over 0 is undefined. Cosine of 5 pi thirds. 5 pi thirds is in quadrant 4, so that'd be over here. And my reference angle, or my distance from the x-axis, is pi thirds. So this would be another 60-degree triangle. Now in quadrant 4, all students take classes. Cosine is still positive, so it won't change. So it should be the same ratio, 1 over 2. They asked for secant of 5 pi 6. 5 pi 6 is in quadrant 2. And the distance from 5 pi 6 back to my x-axis is pi 6. So that would be equivalent to 30 degrees. So I either draw a 30-degree triangle, or I use my left hand, which would be my ring finger that I bend. Secant is going to be the reciprocal of cosine. Cosine is number of fingers to the left, which would be root 3 over 2. Or in my picture, it would require us knowing x, which would be root 3, and r, which would be 2. So either way, I flip this over, or I write it as 2 over root 3, but we can't leave root 3 in the bottom, so we multiply top and bottom by root 3. We end up with 2 root 3 over 3. Tangent of pi 6, that's one we should have memorized. Tangent of pi 6 is going to be our 30-degree angle. So if this is 30 degrees, this is 1, this is root 3. Tangent is y over x, so that's going to be 1 over root 3, but we don't leave root 3 in the bottom, so I multiply by root 3, and we get root 3 over 3. Cotangent of 45 degrees. So either I picture a 45-degree triangle in which x and y are both 1, or that would be bending my middle finger on my left hand, and I would count number of fingers to the right over number of fingers to the left. Either way, we have a number over itself, which is 1. On number 10, I forgot to mention that because I am in quadrant 2 and I'm dealing with secant, it would be negative in that quadrant. So this one should be negative. All right, then we've got cosine of negative 225. Well, positive 225 is in quadrant 3. So that would be going all the way from here to here. So I'd want to go the same distance, which would put me in quadrant 2. So 225 in quadrant 2. I would still be 45 degrees from the x-axis, so I'm picturing something like this. My hypotenuse is root 2, so cosine would be 1 over root 2. Because I am in quadrant 2, cosine is negative there, and I can't leave a square root in the bottom. So this is going to end up being negative root 2 over 2. Cosecant of 300 degrees. 300 degrees is in quadrant 4. Cosecant is a reciprocal of sine, and it is negative. So I need to keep in mind my ratio should be negative. That's going to be 60 degrees from the x-axis, so that would mean looking at this triangle that I drew back here on number 7. My y value would have been root 3. Cosecant is r over y, so that's 2 over root 3, but we can't leave a square root in the bottom, so this is going to become 2 root 3 over 3. Here it says determine where the quadrants have the following things occurring. So on number 15, so remember this is all students take classes. They want to know where cosine and cosecant is reciprocal of sine. So in other words, where are cosine and sine having opposite signs? Well, that would not be in quadrant 1. They're going to have the same there. They would both be positive. This also would not be in quadrant 3 because they would both be negative. So this would be in quadrants 2 and 4. Okay, for number 16, again, all students take classes. They want to know where cosecant, which again is the reciprocal of sine, is negative. So sine could be negative not in these two quadrants. And where tangent is positive, which is only going to be in this quadrant of the two that are left. So quadrant 3. And then number 17 wants to know where cotangent and sine have the same signs. So cotangent is reciprocal of tangent. So this is where they have the same, which means both positive, which could happen here, or both negative. Well, that's not going to happen here or here. So that has to happen here in quadrant 4. So this would be in quadrant 1 and quadrant 4. Next one says, if the terminal side of an angle theta passes through the point -3, 4, determine the numerical value of sine. Okay, so the coordinate point -3, +4 would be in quadrant 2. So it's going to look something like this, where this is -3 and this is +4. I would use Pythagorean theorem to find my missing side. So I got -3 squared plus 4 squared equals my r squared. So that's 9 plus 16, which is 25. And then we take the square root, and we get our missing side to be 5. And they ask for sine, which is y over r, so that would be 4 over 5. Number 19 says, if theta is a 4th quadrant angle, so they're letting us know that it's going to be in this quadrant, so it's not here, here, or here, and sine is -3 over 5. So I'll draw myself a triangle. Sine is y over r. So again, I would do Pythagorean theorem, but this is the same numbers as before, just a different side missing. So this missing side must be 4. And now I'm just going to provide all the ratios. So cosine would be x over r, and its reciprocal would be r over x. Tangent would be y over x, which would be -3 over 4, and cotangent would be its reciprocal. And then cosecant would be the opposite or the reciprocal of sine. So this would be 5 over 3, and it's negative. Okay, number 20 wants us to find the value of r. Well, based on how it's drawn here, if this is a 45-degree angle and this side is 1, this side would also have to be 1, and this side would have to be square root of 2. I know the key says 10 square root of 2. That's because originally this side over here was a 10, not just a 1. Well, if it was a 1, the way I would get from 1 to 10 would be to multiply by 10. So if this side was supposed to be a 1, I'd multiply it by 10. And if this side was supposed to be square root of 2, I would multiply it by 10. 10 times square root of 2 would be 10 square root of 2. So that's where the answer came from on the key. That 10 just did not show up on our review. Number 21 says to find the reference angle for negative 330 degrees. So negative 330 degrees means I'm traveling this direction, 330 degrees, which would put me right about here. My distance from the x-axis would be 30 degrees. Remember, our reference angles are always positive. Then they ask us to find the reference angle for 194 degrees. Okay, so 194 degrees would be somewhere in this quadrant. Fastest way back to the x-axis would be this line here, which is 180 degrees. So I'm just going to subtract 180 from 194 to get the difference to be 14 degrees. Again, reference angles are never negative. Number 23 says to find the reference angle of 5 pi force. So 5 pi force is in quadrant 3. So the distance back to the x-axis would be 1 pi fourth. Okay, number 24. Negative 7 pi tenths. I should know that 7 tenths, if it wasn't negative, is less than 1 and would fall in quadrant 2. But because I'm going the negative direction, negative 7 pi tenths would be in quadrant 3. And I just, again, need to find the distance back to the x-axis, which is pi. So I would have 1 minus 7 over 10. And again, it's always positive. So our reference angle is 3 pi over 10. Number 25 tells us that tangent is negative 3/4. Well, tangent is positive in quadrant 1 and 3, so we know it can't be there. And then it says it exists between pi halves, which is here, and 3 pi halves, which is here. So from here to here would get rid of quadrant 4, so I must be graphing in quadrant 2. So I draw my triangle. Tangent is y over x. So the y value is 3 while the x value is 4, and I know in this quadrant it's the x that's negative. Okay, so again, I could do Pythagorean theorem, but we have already done the Pythagorean theorem for these numbers on the previous page, so I should know this side is 5. So my ratio for sine, y over r, is going to be 3 over 5. And then my ratio for cosine is x over r, would be negative 4 over 5. Reciprocal of cosine would be negative 5 over 4. Reciprocal of sine, which is cosecant, would be 5 over 3. And then lastly, reciprocal of tangent would be cotangent. So this would be negative 4 over 3. Okay, number 26 says a 14-foot tall ladder is used to scale a 13-foot wall. So I'm going to draw myself a picture here. Here's my 13-foot tall wall with a ladder leaned against it that they tell us is 14 feet tall or long. And it says that we need to find the angle of elevation. Remember, angle of elevation means I'm looking upward at something. So that would have to be this angle down here. So here's my angle theta. So I know this side over here, which would be opposite from theta. And I know this side over here, which would be my hypotenuse. My ratio that has opposite and hypotenuse is sine. So I'm going to have sine of theta equals opposite, which is 13, over hypotenuse, which is 14. Remember, to get rid of sine, we take sine's inverse. So I would take the inverse of sine of our ratio 13 over 14 and put that in my calculator. Remember that you do need to make sure your calculator is set in degree mode before you type that in. So we've got sine's inverse of 13 over 14, which is 68.21321, and so on. we typically round our angles to the nearest degree, so this would be 68 degrees. Number 27 says from a point on the ground 12 feet from the base of a flagpole. Okay, so here's the point on the ground 12 feet from our flagpole. The angle of elevation is said to be 53 degrees. So my angle here is 53 degrees. They want to know how tall is our flagpole over here. So flagpole would be opposite. This side that I know is the adjacent, so that tells me I'm using tangent. Tangent of 53 degrees is equal to the opposite side x over the adjacent side 12. And then I'm going to solve for x by multiplying both sides by 12. And I just type this in my calculator. I'll have 12 times tangent of 53 degrees. Again, making sure my calculator is in degree mode. And I'm going to get that x is 15.926 feet. Oh, 16.925, I apologize. All right, and then on the last page, we need to, or the last section, we need to practice our algebra review. So when it asks me to simplify here, the first thing I'm going to want to do is factor top and bottom of both of these fractions. So when I'm asking myself what to put here and here, that comes from the x squared. So that must be x and x. And then here and here has to multiply to give me 8, add to give me -6. So that would have to be 4 and 2, where the 4 and the 2 are both negative. On the bottom of this fraction, what multiplies to give me 6 adds to give me -5 would be -6, and positive, oh, nope, that would be 2 and 3, -2 and -3. For the top of this fraction, what multiplies to give me 12 adds to give me -7 would be -3 and -4. And then in the bottom here, what multiplies to give me 4 adds to give me -4 would be -2 and -2. Now I am dividing, so my rule is to keep, change, flip. So I'm going to keep x minus 4 times x minus 2 over x minus 2 times x minus 3, change from division to multiplication, and then I'm going to flip my fraction x minus 2 to the top and put x minus 3, x minus 4 in the bottom. And then I'm going to divide out anything that matches. So it looks like we have an x minus 4 in the top over here and an x minus 4 in the bottom over here. I've got an x minus 2 in the top here and an x minus 2 in the bottom here. So in the top, I'm left with x minus 2 times x minus 2, or x minus 2 quantities squared, since there's 2 of them. And in the bottom, I'm left with 2x minus 3s, or x minus 3 quantities squared. For number 2, the easiest way to go about this would be to pick a least common denominator. So I look at my two options of denominators. Remember, I can't take anything away. I can only multiply by something to add value to the denominator. So x squared is going to be my least common denominator. That being said, I have to multiply every single piece of this problem by x squared. So x squared times 1 would give us x squared. I can multiply this piece by x squared, but it already has an x squared in the denominator. So what's going to happen is those x squareds will cancel out. So I'll just be left with this negative y squared. In the denominator, x squared times 1 again gives me x squared. I can multiply here times x squared. but there's already an x in the bottom. So this x is going to divide out with one of these x's. So really, I'm just multiplying 1x times y, which would give me xy. I then would factor the top. That's a difference of squares, so that's going to be x plus y, x minus y. And in the denominator, I can factor out an x, which would leave me with x plus y. And then my x plus y's will divide out, and I'm left with x minus y over x. For number 3, again, I'm going to need a common denominator because I am subtracting two fractions. So the first thing I'm going to do is factor these to see what they are. So I asked myself, what multiplies to give me -2, adds to give me a +1 here. That's going to be a +2 and a -1. Here I ask what multiplies to give me -6, adds to give me -1. That would be x minus 3 and x plus 2. So they have this x plus 2 in common, but just like we said before, I can't take anything away. I can only multiply by something to add more to it. So since they both have x plus 2, I'm going to multiply this one by the x minus 3 so that it has that same piece that the other fraction has. But if I multiply the bottom of a fraction by something, rules say I have to do the same to the top. The other fraction is missing the x minus 1, so I want to multiply it by x minus 1. But again, if I do that in the bottom, I've got to do that in the top. So I'm going to multiply my numerators. X times 3 would give me 3x, and -3 times 3 is going to give me -9, all over this common denominator. So I'm just going to abbreviate for now. Okay, over here, I've got 5 times x, which is 5x, and 5 times -1, which is -5, again, all over this common denominator that we came up with. Now that I have a common denominator, I can do what I set out to do, which is subtract these fractions. Remember, that negative goes to both of these pieces. So 3x minus 5x would leave me with -2x. -9 minus -5. Well, minus a negative is like adding. So -9 plus 5 would leave me with -4. All over that common denominator. So here is where we see if we can factor what we have left to see if anything will cross out. So here in my numerator, I can factor a -2. So I'm going to take a -2 out to leave me with x plus 2. All over that common denominator, which was x minus 3 times x plus 2 times x minus 1. Well, these x plus 2's will divide out, and I'm left with -2 over x minus 3 times x minus 1. Number 4 asks if this coordinate point, -1, 1, is on the graph. So I need to substitute those values in for x and y and solve. So here I plug in -1 for f of x, and then I'll have 1 over -1 plus 2 quantity squared. So this would be equivalent to -1 is equal to 1 over, order of operations says I do what's in the parentheses here. -1 plus 2 would be 1. And then I can do the exponent. 1 squared is 1. 1 over 1 is 1, which is not -1. So my answer is no, it is not on the graph. They then say if x is 4, what's f of x? So I'm going to take this value, go plug it in for x. So I'm going to have 1 over 4 plus 2 squared. Again, order of operations says to do inside the parentheses first. 4 plus 2 is 6. I would then need to square it. I end up with 1 over 36. Part C says f of x, so y is 1. So I need to go plug that in here. So I'm going to have 1 equals 1 over x plus 2 squared, and we're asked to solve for x. So I'd want to get rid of my fraction. I do that by multiplying by the denominator. And if I do that on one side, I got to do it on the other. So here, these divide out. Here, I can multiply 1 by this parenthesis, but as we know, multiplying by 1 does not change the value. So I've got x plus 2 squared equals 1. Well, squaring something means to multiply it times itself. So this would be x plus 2 times x plus 2 equals 1. So I multiply x times x times 2, 2 times x, and 2 times 2. These are like terms here in the middle, so this is x squared plus 4x plus 4 equals 1. I want to factor it, but I have to have everything on one side of the equation. So I subtract the 1. This is what we're left with. So then I factor it. What multiplies to give me 3 adds to give me 4 would be positive 3 and positive 1. I'd take my factors and I set them equal to 0 to solve. So I subtract 3, x equals negative 3, and x equals negative 1. All right, and then part D says what is the domain of f? So I go back to my function up here at the top. It is a fraction. Remember, we're not allowed to have 0 in the bottom of a fraction. So I'm asking myself, if I plug in a number for x, what could potentially give me 0? Well, if I put a negative 2 in there, negative 2 plus 2 would give me 0, which I can't have. So x cannot equal negative 2. Here they replaced x with 0, so I'm going to do the same. 1 over 0 plus 2 squared. Again, in the parentheses first, and then I take care of the exponent, and we get 1/4. Here, they replace the x with negative x, so I'm going to have 1 over negative x plus 2 quantity squared. To square something means to multiply it by itself. So I'd have negative x times negative x, which is positive x squared. Negative x times 2 is negative 2x, and again this would be negative 2x, and then I would have a plus 4. So this would become 1 over, when I combine these like terms, x squared minus 4x plus 4. On G, they said to multiply my function by a negative, so I put a negative in front of my entire function. Here it says to replace x with x plus 1, so I'm going to have 1 over, in place of x plus 1 plus 2, quantity squared. In the parentheses first, I combine like terms. I'm going to have 1 over x plus 3 quantity squared, which would be x plus 3 times x plus 3. X times x is x squared. X times 3 is 3x, another 3x. And 9. These are like terms. So I end up with 1 over x squared plus 6x plus 9. Okay, number 5 says for what x values is this true? Where is f of x greater than g of x? So on the graph, I'm going to look for where f of x, which is the solid line, is greater than g of x. This would mean where it is above g of x. And that occurs right here in this section and again out here on the end. So that appears to start at the x value of negative 4 and continues to the x value right here of 2. Or from negative 4 to 2. It starts again right here at the x value of 9, and since this has an arrow on the end, implies that it continues off to infinity, or x is greater than or equal to 9. Okay, then they ask for f plus g of negative 2. This literally means f of negative 2 plus g of negative 2. So I come over here to negative 2, and I ask where does f intersect that line? Well, that would be right here. So we already know the x value is -2. The y value at that point would be 4. So this is 4 plus g intersects that line at the y value of 0. 4 plus 0 is 4. Part C says to find g of f of 2. So I'm going to take f of 2 and plug it in to g. So I come up here to 2, and I need to find where f intersects that line. That would appear to be right here, which is at 0. So this becomes 0. What they're really asking for is g of 0. So right here is the line 0. And I want to know where g touches that line. Well, that would be at this point right here, which is at -4. All right, then they ask for f minus g of 3, which means f of 3 minus g of 3. So I come back up here on my graph. 3 would be this line here. F appears to touch that line here at -1. Minus g touches that line at +1. And -1 minus 1 is -2. All right, number 6. First, part A asks for f of g of x. This is the same as f of g of x, which means take g, plug it into f. So I'm going to take this, and anywhere I see an x, go plug it in. So I'd have 5 plus 3 times, instead of x squared minus 2. So I would have 5, and I need to distribute that 3, so plus 3x squared minus 6. These are like terms, so I would combine those and be left with 3x squared minus 1. This g of f of x means to take f and plug it into g. So I'm going to take this function and replace x with it. So I would have 5 plus 3x quantity squared minus 2. So this means 5 plus 3x times 5 plus 3x minus 2. So 5 times 5 gives us 25. 5 times 3x is 15x. Again, we would have a 15x plus 9x squared. So I've got some like terms here and some like terms here. So we're left with 9x squared plus 30x plus 23. All right, here they ask for the domain. Domain is my x values. So this starts here, which is at -2, and continues infinitely. This could also be written as x is greater than or equal to -2. For my range, the lowest value is on this line, which is at -3, and it extends upward. So from -3 to infinity, or y is greater than or equal to -3. And we have 1, 0 right here at 3. For number 10, my domain starts over here at -7 and goes to this point, but this point covers it. Again, goes to this point, but this point covers it. So it doesn't stop until here, which is at 4. -7 was an open point, and 4 is a closed point. Or from -7 to 4. Okay, it picks up again at 7, +7, at an open circle, and continues to 10, also an open circle. For my range, my lowest value is here, which is at -2. And it comes all the way up to this point, which is at 0. Negative 2 is open, but 0 is closed. And then it has a jump. It comes up here to 2. And stops. And then has another start up here at 3. And continues up to 6. And then stops again, but starts back up again at 8. And looks like we have one x-intercept right here at 4. All right, number 11's domain appears to extend infinitely to the left, but stops here on the right at 8. So it would go from negative infinity up to 8, or that could also be written as x is less than or equal to negative 8. For my range, the lowest y value is here at negative 3, and then this arrow tells us that it extends upward, so it would be from negative 3 to infinity, or y is greater than or equal to negative 3. Looks like we've got two x-intercepts here. I've got one at negative 1 and another one at 6.